Hey everyone! Today I'm diving into a fascinating world of cybersecurity. You won't believe how a single line of code brought a major vulnerability to the Windows kernel. Yep, you heard that right. Let's break down CVE 2024-38063 and see how it exposed Windows to denial of service attacks. So here's the scoop. This vulnerability was hidden in the TCP IP driver of Windows, specifically in the tcp/ip.ice file. The trouble started with a seemingly insignificant change in the IPv6 pprocess options function. Instead of calling ipsenderrorlist, the new code calls ipsenderror. Sounds simple, right? But this tiny tweak led to big problems. Okay, let's get a bit technical. Ipsenderrorlist iterates through a linked list of packets and calls ipsenderror for each item. The modified code skipped this iteration, hinting at issues with list processing. Through meticulous reverse engineering, researchers found that under high network throughput, packets coalesce into a list. This list is where the vulnerability lurks. The author of the blog used a virtual machine to test this theory. Initially, it didn't work because of low throughput. But by limiting the VM to a single CPU core, they managed to force the system to create a large packet list. Wow, bingo, the vulnerability was confirmed. Now let's talk about ipsenderror. This function handles erroneous packets by disabling them and sending an ICMP error message. However, when dealing with a malformed options header, it attempts to send an ICMP error for each packet in the list, setting the packet size to 0. This behavior raised the possibility of a race condition and opened up more avenues for exploitation. But here's where it gets even more interesting. The packet handler relies on a previously set header value, allowing processing to continue even with a zero-size packet. This anomaly meant that researchers could manipulate the header value to control which parser is invoked. After some digging, the focus turned to the IPv6 fragment parser. Guess what? They found an integer underflow vulnerability. While it didn't lead directly to remote code execution, it allowed for information leakage and memory manipulation. Another researcher even published a proof of concept demonstrating a different exploitation path. This just shows how collaborative and dynamic the cybersecurity community is. And that's a wrap on how a single line change exposed a critical vulnerability in Windows. If you found this breakdown intriguing, hit that like button and don't forget to subscribe for more in-depth cybersecurity analyses. Stay safe out there.